In this section, we're going to be doing problems that you could have done with a binomial distribution, but we're going to actually use a normal approximation. There are a couple of reasons we went to it. Honestly, calculators are pretty good at binomial distributions now, but it used to be when we had large n's, the numbers got too big to be calculated, so we wanted to find a different way to calculate it. So here's the approximation. First of all, let's go ahead and revisit the binomial distribution. The probability that someone tries to pad their insurance claims, and you're going to recognize this problem from your assignment, is 40%. Obviously, I've changed the numbers. You receive 90 insurance claims. What is the probability that exactly half are padded? So this is a traditional binomial distribution where I know is P is 40%, better yet, write it as a decimal, and N is 90. I want to find the probability that half are padded, and half is 45 claims. So I'm actually going to show you what the normal binomial distribution looks like. Notice these little spikes. I could have 28 or 29. I don't have 28 and a half, by the way. And 45 is over here. Why is it over here on the end? Well, because if 40% are padded, we expect that 40% are padded and we have 90, we would normally expect 36 padded claims here. This is above average, so that's why it's over there. Well, to calculate the probability, all I have to do is use binom PDF, right, which is 90, comma 0.4. It's NP and X. Don't forget that formula. And I can just go ahead and calculate it right now. Second distribution. Have to scroll all the way down for those distributions. There it is, binom PDF. We're doing only one value, so it's not CDF. 90, comma, 0.4, comma, and we wanted to get 45. And there's your answer, 0.0134. All right, now let's say we try to do a normal approximation, because you noticed I did calculate mu, right? So maybe I can do that, and we had kind of been playing with that before. So here's my givens again, and I'm going to try and find the probability that x is 45. Well, to use normal CDF, I need a z-score. So I need first to calculate mu, which is 36, and then to calculate sigma, and I'm getting about that number right there. Let's go ahead and calculate a z-score. That's x minus mu. Remember, x was 45, mu is 36, and there's my sigma. And I'm getting about 1.94. So I should have to do normal CDF of 1.94, right? So let's go ahead and do that. And I got an error, so that didn't work. Maybe it's because I only had one C. I'm supposed to have two. So let me try with 1.94 twice. I got 0. Well, that didn't work. I'm trying to get 0.013. Maybe if I do to 1,000. That didn't give me the right answer. So what went wrong? Well, what went wrong is that the normal this is a binomial distribution here on the right. The normal distribution is completely solid and shaded. So if I overlap those two, now you can see it here, you can see that if I'm trying to approximate 45 on a binomial, it's fine because it's one spike. I don't have 44.5 on a binomial. So how can I take care of doing this approximation when I have every point shaded in between? The normal is a continuous distribution. So first of all, we're going to do what's called a continuity adjustment. So let me go ahead and bring in a picture. And we still need two z-scores for x equals 45. So I'm going to make a box around 45. It's going to be width 1. And the left side is going to start half a unit before at 44.5. That's going to be my x1 to find my z1. And my x2, I'm going to go half a unit above, and that'll be 45.5. All right. Now I can calculate my first z-score. There's 44.5 minus 36 over my sigma. And there's my second z-score. And now if I do normal CDF with these, let's see what we get. I got 0.0129, which is very close to the 0.0134 that we got on Binom PDF. So basically, by the way, if you do an assignment on WebAssign and it has you do this part first and that part second, WebAssign's being kind of finicky. Use this number for the second one on the J3 assignments. So, but first of all, try to do this one. And if it's not working, try to use I'm sorry, use that answer, try that one. And if it doesn't work, use a binom. Okay. So some general rules to find the probability that x is exactly a number. You need two x values to use a normal approximation. So you find so you can find two z values later. So x1 is going to be minus 0.5 and x2 is plus 0.5. And you also need mu and sigma if they're not given, and usually they're not. So you're going to have to do the NP calculation and the square root of NPQ. Then you're going to calculate the two z values. And then finally, you're going to do normal CDF with those two z values, and it should spit out the right answer. Remember on WebAssign to round your z values to the hundredths place. And your probabilities, if they're decimal form, we tend to give to the 10,000ths place.